In this video, we're going to be solving systems by graphing and answering the question, how do you solve a system of linear equations by graphing? First, we need to know what a system of linear equations is. And that's a set of two or more linear equations containing two or more variables. The solution to the system of linear equations is an ordered pair xy that satisfies each equation in the system, or simply xy that makes that system true. Let's look at an example of solving a system. First, given the equation y is equal to 1/2 x plus 2, which I'm doing in blue here, I'm going to graph that individual equation. Then, given another equation, y is equal to negative 1/2 x plus 5, which here I'm working in green, I graph that equation in green. I'm using red to draw lines to the x and y axis to help me isolate the number of their location. I see that x is at 3 and that y is at 3.5. So my answer is 3, 3.5. It's important to always check your answer back at the original equations, both of them, and make sure that your new x and y solution will satisfy them both and make each of them individually true. Let's look at another example where in blue I give x plus y is equal to 3. I'm going to graph that equation using the x and y intercepts onto the graph in blue. In green, if I have the equation x minus 2y is equal to 3, I'm going to graph that in green onto this graph using both x and y intercepts. I can see that they cross on the x-axis at the point 3, 0. And just as before, it's important that you go back, substitute these answers into the original equations, and make sure that they satisfy it and make it true. A good keynote to keep in mind is that the linear equations that make up the system can be in slope-intercept form, y is equal to mx plus b, standard form, ax plus by is equal to c, or point-slope form, which is y minus y sub 1 is equal to mx minus x sub 1. Every time you try to work on a problem and it doesn't work, you're one step closer to finding the solution.